Here we're looking at compound events with and without replacement. Now, if you're looking at a situation without replacement, by far the best way to model it is using a tree diagram. So I'm going to do all of these problems using a tree diagram so you can compare what they look like. So we'll start first of all with replacement. So we have this case 1. One ball is taken, replaced, and then a second ball is taken. So if we think about what can happen the first time, we could take a red ball or we could take a blue ball. Now, one of the advantages of a tree diagram is we can actually write the probabilities on it. So there are 6 things that can happen, and 4 of those are red, and 6 things can happen, 2 of those are blue. Now, of course, we can simplify these fractions. This is the same as 2/3, so I'll write that instead. And this is 2/6 1/3. Okay. Right, now if I take out one of these balls at random and then put it back, the second time I take out a ball, the probabilities are exactly the same. The situation is the same. So these are independent events. So I get the same probabilities. Oops, should be 2/3. Okay, 2/3, and this is 1/3, and again 2/3 and 1/3. So if I now look at events such as the probability of getting 2 red balls, I very simply just follow the branch that would give me that outcome, a red ball followed by a red ball, and I multiply the probability together. So the probability of getting a red and a red is 2/3 times 2/3, which is 4/9. Sometimes you might need to find the probability of something that can happen in more than one way. So for example, you might look at the probability of the balls being different colours. In other words, there's a red ball and there's a blue ball. So we can get that by getting a red ball first and then a blue ball, or getting a blue ball first and then a red ball. So we're looking at these 2 outcomes would give us balls of different colours. So the calculation we do there is this. So probability of 1 red, 1 blue. Okay, where the order doesn't matter here. It's just I want them to be different colours. So I say, okay, well, how can I get to this branch, because this is a red and a blue? Well, again, if I'm going this way through the branches, I just multiply. So it's 2/3 times 1/3. But I could end up with balls of the same colour going this way. So if I've got another option, I do an addition. This is an or. So the multiplication corresponds to and. I want red and blue. Or I want blue and red. So this is the red and blue here. Or blue and red. So that would be 1/3. Okay, that gives me the blue. And then the red one after that is 2/3. That's 2/3. And then working this out, well, I've got 2/9 plus 2/9, which is 4/9. Okay, so the probability of them being different colours is 4/9. Okay, now this is a simple case because I'm putting them back so the situation doesn't change. Now, if I now do it, I've changed this to case 2. Okay, case 2, 1 ball is taken, and then we'll have a not replaced. Okay, let's change the problem slightly. Not replaced, and then the second ball is taken. Right, now the diagram has the same structure, but the probabilities will be different because, for example, if my first ball is red, then one of these balls has gone. Right? I've taken it out. So looking at the probabilities of red and blue after that, I get different values. So if I've already had a red ball, the probability that my second ball is red is 3 out of 5. And the probability that it's blue is 2 out of 5. Okay? The numbers have changed. The probabilities have changed. Okay, well, what if the first ball is blue? Okay, so let's take one of those out. There's the first ball. Okay, well now the probability of the second one being red is 4 out of 5. And the probability that it's blue is 1 out of 5. So if we ask the same questions, probability that it's red and red, we'll now get 2/3 times 3/5. which is 2/5. And it's a different value. And if I look at the probability of the colours being different, okay, so this is the same as one red and one blue, any order. So again, I'm looking at these branches. It could be red and followed by blue, or it could be blue followed by red. So I get 2/3 times 2/5, or 1/3 times 4/5. So this would be 4/15 plus, again, 4/15. So that would be 8/15.